Hi guys, welcome back. I'm going to do our third and final example here, okay? We are looking at the projectile motion of Pisa volcano, okay? So we have a volcano, okay? And it has projected rock fragment, okay? At a velocity of, let me zoom in here, a velocity of 25 meters per second at an angle of 35 degrees, okay? And it states that it lands negative 20 meters or 20 meters below what I'm gonna call zero, my initial positions, okay? All right, so again, I'm going to say at this point, my x0 is 0 meters. Same thing with my y. My x0 and my y0 are going to be 0 meters. Okay, so again, let's label some things that we know. So we know that there's some gravity. Okay, we know that at the peak, or I'm sorry, we know that at the end, let's see, what do we know here? Sorry, I got to think about this for a second. Oh yeah, at our end here, my y is negative 20 meters, not degrees, meters. Okay. Our V naught is 25 meters per second, and that will have an x and a y component. We have some theta naught as 35 degrees. Okay, what else do we know? We don't know our distance here. Okay, so our first question is, how long does it take for that rock to follow that path and end up here? Okay, the second one is going to be, what is the magnitude and direction of the velocity of the rock's impact? Okay, so this is going to be a little bit of a longer one, so bear with me, okay? All right. So, part A. We want to know our time, okay? And we know our acceleration in the y direction is negative g. We know our x naught and our y naught and our y. So let's see what we can use here. So we know our y, we know our y naught. Do we know our initial y? Yes, we can find that. We know our g. Okay, so why don't we use this equation here? Okay. So we're going to use y equals y naught plus v naught y times t minus 1/2 g t squared. Okay? All right, so this is going to take a bit of doing. Okay? So I'm going to make this a little bigger. Okay. I'm going to start plugging in my values. Okay? So my y naught is 0, so I'm going to cross that out automatically. But that's the only thing I can cross out. Okay? I am going to start plugging things in. So my y here is negative 20 meters. And my v naught y is going to be v naught. So 25, meters per second times sine of theta, which is 35 degrees. Okay, times time, times t, minus 1/2 times g, which is 9.8 meters per second squared, times t squared. Okay? All right, so let's see here. Let me bring them all to one side, and then maybe this form will look a little familiar. Okay, So if I bring this over and put this out front, we're going to have negative 1/2 of 9.8 is 4.9. Okay, times t squared plus 25 meters per second. Let me use a calculator. 25 times sine of 35. We get 14.4, or I'm sorry, 14.3 meters per second times time. Okay, and then I added this over, so plus 20 meters. Okay. Okay, so again, we're trying to solve for my t here. And does this form look familiar to anybody? Let's think about this for a second. Does this form look familiar? It should look something like this. 0 equals a t squared plus b t plus c. Does that look familiar? Okay, that's a 0. Okay, so in order to solve for my t, I will need to look at it in this form, okay? And I'm going to need the quadratic equation, okay? So my quadratic equation is going to be t equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay? Hopefully this looks familiar to you guys. All right, so this is exactly how I'm going to solve for my time here. Okay? So I can either divide by a negative throughout. That's what I would do because I like that first number to be positive. But that's not necessary. You don't have to. But if I multiply throughout with negative, I get a positive here, negative here, and a negative here. And it doesn't affect that 0. So we can totally do that. Now I'm going to use this quadratic equation to solve for my time. Okay, so t equals negative b, and my b here is going to be negative 14.3. Okay, negative 14.3 meters per second, plus or minus the square root of negative 14.3 squared minus 4 times a. This is my a. So 4.9 meters per second squared times c. So my c is going to be negative 20 meters. Okay, so that's one big square root. And I'm going to divide that by 2 times a, 4.9 meters per second squared. Okay? All right, so now, okay, I'm going to use some algebra to kind of condense this. Okay, so negative times a negative is 14.3 meters per second. Okay, and then in my square root, I have 14.3 squared. 14.3 squared. So that's going to be 204.5 meters squared per second squared minus 4 times 4.9 times 20. And this is a negative times a negative, so that's a positive. That comes out to 392 meters squared per second squared. And all divided by 4.9 times 2, which is 9.8 meters per second squared. Okay. All right, so 14.3, I know that this is a lot of math, a lot of algebra, and that's what physics is, so bear with me, okay? So 204.5 plus 392, take the square root of that number, and we get 24.4. And we're taking a square root of meters squared per second squared, so we end up with meters per second. Okay. Okay, so this is where it might be a little bit funky. So we have a plus or a minus. So I'm going to get two different answers. Okay. So I would first take my 14.3, add 24.4, and divide it by 9.8. Okay, so I'm going to do that first. So 14.3 plus 24.4 divided by 9.8, and I get 3.95. Okay, and let me look at the units. So I get a meters per second up top. Meters cancel, one of the seconds cancels, so I'm left with seconds. Okay, now let me do the other value. 14.3 minus 24.4 divided by 9.8, I get a negative 1.03 seconds. Now, remember that we're solving for time, okay? And remember that time can't be negative. Okay, so this answer is automatically crossed out. So remember earlier, I talked about if you ever get a negative value for that time, then it's not a good value, throw it out, okay? So we want to keep the positive value, okay? So now, that is my time that it will take my rock to follow that trajectory, okay? And end here, all right? Okay, so let's look at part B now. Part B asks, what are the magnitude and the direction of the rock's velocity and impact? Okay, so we know all of these things, okay? Let's see. We now also know that our time is equal to 3.95 seconds, right? Yes, okay, just want to make sure. So now we want to know the magnitude and direction. Okay, so we want to know the magnitude and the direction. Whoa. Okay. Okay, so remember, looking back here, to figure out our magnitude and direction, this is how we do it. We say, okay, our magnitude v equals the square root of vx squared plus vy squared, and our direction, which is defined by our theta, or angle, is the tan inverse of vy over vx. Okay, so those are the two main equations that we need to solve. Okay, so again, v equals vx squared plus vy squared, square root of that, and then theta equals tan inverse of vy over vx. Okay, so that means that I need to find these two values, my vy and my vx. Okay, so we know our initial, okay, for each one. And in case you forgot, okay, hopefully you guys remember, in the main lecture, that my velocity in the x direction remains constant throughout these trajectories. Okay, so if I solve for my v naught x, I've already solved for my vx. Okay, so let me just go ahead and do that real quick. So my v naught x is going to be v naught times cosine of theta naught. Okay, I can just make sure of that. Yes, cosine. Okay, so what is my v naught? My v naught is 25 meters per second. Okay, so there's my v naught times cosine of 35 degrees. Okay, give me just 1 second. Okay, sorry about that. Let me continue. So we have our velocity in our x direction equals our initial velocity in our x direction. Okay, so here we have our velocity, our initial velocity, times our cosine of 35. Okay, so let me go ahead and do that calculation. 25 times cosine of 35. Okay, that is going to be 20.5 meters per second. Okay, so now we have our Vx. So we're halfway there. Okay, now we need to find our Vy. Okay, and we are going to have to use one of these equations over here. Okay, whoops. Where'd my equations go? There we are. Okay, so we know our V naught Y, we know our G, we know our time now. Okay, so let's use this equation here. So Vy equals V naught Y minus GT. Okay? All right, so our V naught Y again is going to be our V naught times sine of theta naught minus GT. Okay. Our V naught is 25 meters per second times sine. Theta is 35 degrees. Okay. Our G is 9.8 meters per second squared. And our time we just solved for is 3.95 seconds. Okay, so use our fancy calculators. Calculate this. Sine times 35 minus 9.8 times 3.95. And we get a negative 24.4 meters per second. Okay, so now we have our Vx and our Vy, so we can calculate our velocity, magnitude, and direction. Okay, so let's go ahead and do that over here. So my V is going to be 20.5 meters per second. And then we're going to square that. That's our Vx. Okay. Plus our negative 24.4 meters per second squared. That is our Vy. Okay. And then plug that into our calculator. 20.5 squared, 24.4 squared. We get plus or minus 31.8, 31.9 meters per second. Okay, and remember that we're looking at our magnitude, so we're just going to take that positive value. Okay, so we're just saying it's 31.9 meters per second because that's going to be our magnitude. So we're not worried about our direction quite yet. Okay, so that's our speed. You can also call that our speed. Okay, now we want to know our direction. So we are going to use theta equals tan inverse Vy is going to be negative 24.4 meters per second over Vx, 20.5 meters per second. Okay, now I can plug that into our calculator, and it is important to get that negative in there, okay, because that will tell us which direction our velocity is going. Okay, so I calculated that, and I get negative, I'm going to say about negative 50 degrees. Okay, so that is my direction. Now, what does that negative tell me? Remember, we talked about this in, I believe, we were looking at vectors, that typically when we're measuring angles in our XY coordinate system, we are going this direction, or counterclockwise. That negative tells me I'm going to be going the opposite way. So my 50 degrees, say that's about right there, okay? I'm saying that this angle here, theta, is negative 50 degrees. Okay, so that's that smaller angle. Okay? All right, so that is our last example. I'll be posting these, and if you have any questions, feel free to contact me through Canvas or email. Either works. All right? Have a good week.